Howdy, y'all. I'm so excited today that we get to talk with two of the authors of this new amazing paper titled Review of Curriculum-Based Measures in Mathematics, an update and extension of the literature. CBMs are commonly used for both universal screening decisions along with progress monitoring students. And so now I'm going to turn it over to two of the authors.
Awesome. Thanks for having us, Corey. My name's Allison Kiss, and I'm currently a practicing school psychologist up in Anchorage.
Hi, everyone. I'm Gina Nelson, and I'm an assistant research professor at the Center on Teaching and Learning at the University of Oregon. All right, and now Allison and I are going to talk a little bit about the rationale for the study, the methods that we used, and some of the results. All right, so curriculum-based measures were developed to identify students in need of intensified instruction or intervention, and then to monitor the effectiveness of instructional adaptations that teachers make while students are in intervention. Some of the earliest iterations of CBM mathematics focused on computation and concepts and applications. However, recently, CBM mathematics has expanded to include other areas of math, including word problem solving, early numeracy, and algebra. And today, schools continue to use CBM mathematics as part of MTSS practices and frameworks, and research in CBM mathematics has grown considerably in recent years, meaning that we need to have a better understanding of the current evidence base for CBM mathematics to inform MTSS practices in schools. Right, so in 2004, Lynn Fuchs outlined the need for 3 stages of CBM research. And the first stage of CBM research includes a 1-point-in-time assessment, which most of you may recognize as screening. And evidence for this stage of research includes forms of reliability and validity. Stage 2 includes evidence for repeated use of curriculum-based measures in mathematics for progress monitoring over multiple time points. And evidence at this stage includes weekly slope or validity of the slope. And then finally, in stage 3, this refers to instructional utility, or the relationship between teachers' use of curriculum-based measures and student outcomes or student achievement. And as part of the current systematic review, we coded for different variables across these 3 stages of research, and we coded for a lot of different variables. And in order to keep today's session brief, we just included a QR code to our coding protocol in case anyone is interested in looking at all of the different variables that we coded for across studies. Right, and a previous literature review guided the framework that we use to conduct the current literature review. So in 2007, Anne Fagan and her colleagues conducted a literature review of progress monitoring measures in mathematics. And they found that the majority of studies focused on the technical adequacy of measures used in elementary grades, so through 5th grade. And most of the curriculum-based measure mathematics research focused on computation skills or basic facts. And the authors found that only 4 studies were conducted with early mathematics or grades kindergarten and 1st grade. And again, only 4 studies were conducted for grades 6 through 12. So given the recent uptake in literature related to curriculum-based measures in mathematics, now was an appropriate time for us to conduct a new systematic review to see what the evidence is currently showing. And so we had a few research questions that were guiding our study, including what is the current state of evidence for curriculum-based measures in mathematics used for screening and progress monitoring? To what extent does the research address the 3 different stages of curriculum-based measure development? And then what are the areas of overlap and distinction from the results of the previous review conducted in 2007 with results of the current review? And finally, what are the continued or newly identified gaps in the research on curriculum-based measures in mathematics, and how can these limitations be addressed in future research? Right, so just briefly to go over some of our methods, we searched the literature from 2005 to March 2021. We picked the 2005 cutoff date because that is some of the latest published work in the previous review by Anne Fagan and her colleagues, and the search was conducted in March 2021. We used a lot of different methods to identify current studies. So we looked at electronic databases, we reviewed table of contents from relevant journals. We also looked at reference lists of previous reviews, and we did a forward citation search of the previous review on curriculum-based measures in math. And we identified 2,817 abstracts, from which we then looked at the full text to determine which articles would be included in our systematic review. And ultimately, we identified 99 studies that met inclusion criteria for the current review. And the current review includes studies from preschool through grade 12 that specifically sought to investigate one of the stages of curriculum-based measures outlined by Lynn Fuchs in 2004, and included evidence for us to synthesize in the current review. All right, so now I'm going to turn over the presentation to Allison to discuss the results.
Yeah, awesome. I get the pleasure of sharing some of the results that we found. And so I'm really excited about this study just because working in schools, this is a question that would come up a lot. Like, what do we use for math? What do we use to progress monitor in math? And you'd come up with this previous review from 2007. They're like, okay, that's kind of old. Like, do you have anything else? And so now I'm very excited because we do have something else. And so, like Gina mentioned, across our search, we found 99 studies. And very similar to the previous review, the majority of these studies were still done at that stage 1 research, really looking at evidence for one point in time. Can we use this assessment to identify students at risk so that we can help provide intervention? And so you'll notice that these numbers don't add up to 99, but that's because some studies might have included both elementary and secondary, or some studies included across early math tools and also tools in elementary. And so we also found throughout the content focus, we saw a lot of measures on that computation, which was, again, very similar to the previous review. But I think some of what is exciting is we were able to locate 40 studies that looked at stage 2. So there's 40 studies out there that specifically were looking at using CBM math for progress monitoring across pre-K through 12th grade students. One thing that we did find, there's really not a lot of studies out there looking at that stage 3 research, which is not necessarily looking at, can CBM math is it instructionally useful? But it was really, we were looking for studies that showed that the use of CBM math led to increased student engagement. So it's definitely a gap in the work that we can still use some progress on. One thing we noticed with the content focus as well is there are some researchers out there looking across some new types of measures that weren't really addressed in the previous review, things like algebra, word problem solving, fractions, and geometry. And you could see there are a lot more early math studies too. So lots of more research. And so I really love this graphic because I think it shows just how much progress we've made in the field of research looking at CBM math. So on this figure here, the lower part of the bar graph, that darker shade, that indicates the number of studies that were included in the previous review. And you can see at first we look at stage 1, stage 2, and then stage 3 for that early math level. And then same thing for elementary, same thing for secondary. And so you can see we've definitely had a really great increase in studies over the past 15 years, especially looking at evidence for screening with early math measures and also with measures at that elementary level. And I think you could also see a lot of growth. Yeah, just across the board, stage 1 was really dominating the field with what the empirical evidence said. But one positive that I really see as well, even though it's still less than stage 1, the amount of growth we see with those stage 2 studies, right? I mean, at early math stage, we went from just 2 studies in the previous review, and we were able to locate 19 more empirical studies that were really looking at how can we use this to monitor our students' growth. And so just to kind of summarize some of those key findings, the amount of research since that last review has tripled, which is amazing to see people doing this work across the country. And again, most of the research on CBM and math is really at that elementary stage, looking at that screening, which I'm not super surprised at, because I think that's what a lot of schools are doing right now. Like when we look across schools in the United States, people are, when it comes to math, we're screening for math. But then at least personally, when I talk to teachers, it's that progress monitoring piece that we still need a lot of work on in the field as well. And there's definitely been considerable growth in that early math and secondary math over the past 15 years, which is exciting to see. And then on this next slide, Gina and I really wanted to highlight a resource that we created. So we know that educators in the field, administrators don't necessarily always have access to read these empirical studies. So what we did is tried to just highlight a lot of our key findings. We looked through our article and found a way that we rated the evidence for different measures for both screening and progress monitoring. Definitely computation measures at elementary school seem to have the most evidence for both screening and progress monitoring, and also those early math stages. Whereas across other grades and different types of CBM, we saw more variability that, for example, with computation at the high school or middle and high school level, there was some evidence for screening at middle school, but then not so much progress monitoring and not so much at the high school level. So you can see where some of those gaps are. And if you're really interested and excited about all the psychometric details, do check out our article, because we've got, I think it's over like 15 pages of tables with all the details if you really want to dig in. But with that, I think we'll kind of turn it over to Corey and talk a little bit more about the article.
Yeah, this is so amazing. And I'm so happy that you all were able to share some of the results. So one of the questions that I've gotten from a lot of teachers and then also district personnel is this idea of screening decisions and then progress monitoring. And so teachers or administrators will ask, can I use the same measure for both, or do I need to use different measures for screening versus progress monitoring? And so what would it mean for a specific type of CBM to have strong evidence for screening-based decisions? And then what would it mean for a CBM to have strong evidence of progress monitoring decisions? And why might it occur occasionally that a measure might be strong in one area and weak in the other?
Well, I can start with what we would be looking for screening measures. And just to kind of recap some of the things that we looked for in the studies included in our review, we were really looking at those stage 1 studies for screening, what evidence of reliability and validity authors were able to report for the measures, or for the curriculum-based measures. And for reliability, you'd want to consider test retest reliability, internal reliability, and an alternate form reliability. And validity, you'd really want to know, is the screening measure that I'm giving to students able to, or is it related to the content for a general or an outcome measure at the end of the year, such as a state test? So how closely related is a student's score on the screening measure to how accurately can you predict how well they'll do at the end of the year, for example, would be one example of validity.
Yeah, awesome. And then for progress monitoring, I think there's quite a few things that you'd want to look for. I think one of the most important things is we want our progress monitoring tools to be brief. We know there's not a lot of time in the school day. What I've noticed, and I think trends across the US, is a lot of schools will have this reading intervention block. And then when it comes to math, it's like, oh, like maybe we could squeeze that in somewhere. And so if we're taking time where we're really frequently monitoring a student's progress towards something, we want to make sure that that's really quick so that we can really prioritize that instructional time. And then we also want to make sure it's reliable in the sense that if I'm giving a form of this assessment one week and then the next week, we want to make sure that the difference in the score is related to the student's growth and not just something different about the measure that we're using. And then I would say one of the other important things to really look at that we looked at in our study was things like weekly growth rates and if the slope can be predictive of later success. So what I mean by that is, if we're collecting this data weekly, we want it to be sensitive to student growth. We don't want to have to wait, 5 months to be able to know if the student made progress or not. We really want to be able to know if that growth rate is at a level that we can see, in 6 weeks, we can check in and make some changes if that intervention is not working. And when I mentioned like the predictive validity of the slope, we want to know if then we could look at that student's growth rate and use that information. Like, is that going to tell us how they're going to do at the end of the year, right? Because we would hope so. We would hope that if the student's making progress, they're going to make progress on other measures at the end of the year as well.
Yeah, and it's interesting you bring that up because that's one of the same issues they've looked at with reading CBMs and specifically looking at oral reading fluency and identifying basically how many data points you would necessarily need in order to have a slope that's reliable enough to predict the end of the year performance. And Gina, one of the things that you mentioned that I would feel bad if I did not mention this, given some of the work that Amanda Vanderheyden, Burns, and Cotting have done, is specifically thinking about base rate. And so like you can have a really great universal screener that has strong psychometric properties in previous studies, but if the base rate of students who might theoretically be at risk is really high, all of your all the psychometrics you might get from your screener are now super flawed. And so like really trying to figure out at a school district site, thinking through what screener to select, but then also interpreting your data appropriately is definitely super challenging. I had another question for y'all. Specifically, when you think about, we now theoretically have some CBMs that you all identified appear to provide psychometric data that's reliable and valid across studies. What would be some of your recommendations for thinking about administration fidelity of the CBM? So like how would a school district, they're going to adopt a CBM, but what concerns might they have about administering with fidelity, scoring with fidelity, and then interpreting with fidelity?
Yeah, I think it definitely depends a little bit on what sort of tool the district is using, because one of the things that's really great about CBM math is a lot of these tools can be free and just like downloaded and printed online, right? So I feel like there's that option, but then there's also those tools that are part of like comprehensive assessment systems through different publisher vendors, right? So whatever tool you're using, I think it's really important to make sure that you're following whatever that recommendation be, whether it's from that tool online or from that published vendor, and making sure that the district or the school has a training plan. We don't just want to throw stuff at teachers and say like, oh, here's this new measure, start using it with your kids, right? We want to make sure that they understand how to give it, and more importantly, how to really interpret that data. And I know like some schools, I mean, one thing that might really help, and while this wasn't necessarily addressed in our study, but just kind of professionally, one thing that would really help is making sure like maybe there's a check-in at the start of every year, so that if you have these assessment tools, you want to make sure that every teacher's trained on it and that they're using it in an appropriate way. Or maybe some schools might have someone like an instructional coach or an MTSS coach, where maybe they're the person collecting this data, and that way they can kind of be in charge and give more time for the teachers to really focus more on the instruction. But I think it's just really important for districts as a whole to not just jump to using a measure without really thinking through like who's going to be administering this and who's going to be interpreting it, and how are we going to actually be using it in the day-to-day to make decisions.
And then something to add related to that for progress monitoring, I know that a lot of schools struggle just with intervention time in general, and a lot of times that intervention schedule doesn't provide a lot of flexibility if you run a few minutes over, and making sure that you're collecting the progress monitoring data regularly for students who are receiving intervention, and not skipping kind of those check-in points with students in order to make sure that you know if any other instructional adaptations need to be made.
Yeah, that's great. One of the things that I find fascinating is just, as Allison, you had mentioned this, as schools might be adopting computer-based CBMs, how the technical adequacy of students typing numbers on a computer or even an iPad versus actually handwriting them, how that might distort some of this. But I think that's an area that needs a lot further work. And so I had one more question. Outside of CBMs for screening-based decisions, there's a lot of computer adaptive tests that are schools are picking up that are, actually, I don't want to name any names, but there's a whole bunch out there that are within, that would fit this idea of computer adaptive, which means a student's response on a computer would then funnel them to differential items based on how they're responding. And I know a lot of the computer adaptive screening measures oftentimes do take more instructional time for assessment. So a lot of the CBMs might be 2-4 minute time blocks, where a lot of the computer adaptive screening measures will take anywhere between 15 to 30 minutes, depending on the student response and the nature of the task. So I say all that, what, from y'all's work, what would you say are some of the pros or cons of some of the computer adaptive tests used for screening decisions?
Yeah, definitely. So we didn't really include computer adaptive tests in our review. We really wanted to stick to that CBM math, but I could speak to that just in general of what we know from the field at this time. And I like that you had mentioned that assessment time. I mean, I work with some students and they've taken like an hour and a half for some of these tests. It can be really lengthy, especially if it's students that struggle with attention or have some difficulties really focusing, and then or they might just click through the test, and then how much does that data really show about them, right? But so I think back to your question, thinking about computer adaptive tests, I think there is some work out there showing that they might be great tools for screening in the sense that they do encompass a really broad area of mathematics and looks at different domains. And there's some good reliability evidence and some evidence showing that it can be used to predict if students are at risk and might need intervention. But I think where some of the benefits of CBM in comparison is that option to be able to use some of the CBMs to screen and then also use that same measure to monitor progress, right? Because when we're monitoring progress, we want to make sure that that's brief, like those CBMs. I mean, some are even 1 minute, right? Versus we don't want to be having students take this 20-minute computer adaptive test every few weeks, because that's taking a whole intervention session for that kid where they could be getting that time with their instruction and their intervention, really focusing on improving their growth. So I think just for districts in general to really think about, like, if you're considering that other type of assessment, how are you going to use it, and making sure that if you are choosing to use a computer adaptive test, you're really weighing the benefits and pros and cons and realizing that that's taking a lot more instructional time that students are going to miss.
Okay, and I'm going to throw y'all a curveball because we didn't talk about this ahead of time.
Right,
I actually have one more question after doing all this chatting. And so historically, right, screening-based decisions have been like, we pick a screener, we pick one instrument, we kind of screen, and we move from there, minus a lot of the early math CBM work, which y'all included in your review, oftentimes encompasses kind of those big four of quantity discrimination, missing number, one-to-one correspondence, and then oral counting. But there's been a movement recently by like Solomon's done some work on this, Van Norman's done some work, and Vanderheyden talking about how you might think about using gated type screening approaches. And so I'm wondering if did you all happen to identify any studies in your review that use gated screening approaches, or were most of the studies like one instrument, they use it and then they walk away?
Mm-hmm.
So I can talk a little bit about this. I'm currently working on a review of gated screening approaches in mathematics. So this
perfect segue then.
There were a few studies that we did identify for the current review related to gated screening. However, not very many studies have that were included looked at that. And I think there are pros and cons to gated screening approaches. And Allison and I haven't actually talked about this, so she may agree or disagree with me. So we'll have to see what she says. So I think that adding in another screener has some benefits that it allows you, well, first of all, you can get a little bit more information about students, especially students who maybe are identified as potentially failing a high stakes test at the end of the year, such as a state test. You may be able to get more information if the second screener as part of the gated model is giving you more diagnostic information about the student that can help you inform instruction. However, when you look at the psychometrics behind gated screening, what I've seen is that with the gated screening approach, it can lead to fewer false positives, however, a greater number of false negatives, meaning students who actually need intervention may be missed in a gated model, which there's pros and cons to that too, because if you're identifying fewer false positives, meaning you're kind of identifying fewer students who don't need intervention, it could save some resources who actually don't need intervention. It could save the school resources. But if then that's weighed against identifying increasing the number of false negatives, it means you're missing students who actually need intervention. So I don't know that that actually gives a solid answer to your question. I think that the work in gated screening is still a little bit emerging, and we need to do more work in that area across grade levels and content areas. So Alice.
Yeah, I think I definitely take the stance if you're going to do more than one screener, like the second one should definitely be something that's you're using to get more information about potentially matching a student to a different intervention. So it kind of depends, I would say, on the resources in your district, right? If you just have one option for a math intervention, I would probably say, let's just give the one screener and get kids in those interventions, or modify how we're teaching instruction in general, depending on how many students are at risk, compared to, maybe you have a number of different interventions, and that second tool that you're using, if you're using it to kind of better place, like, okay, who needs this type of intervention and who needs this other maybe computation-based intervention, I think it might be helpful. But I would just say making sure that if you're giving a second screener, it should be probably something super brief so that you're not delaying getting kids the interventions that they need.
Yeah,
but I'm excited to see the results of your review, Gina.
Yeah. And something else to mention too, there's a lot of different ways to do gated screening. So it also depends on, are you going to give a second measure, or are you going to use the previous year's state test scores, which means you don't have to give another measure. You don't add that time. You already have those data. So I also think it's a balance of how much more time are you going to need to give the second measure, if in fact you need to give the second one, as opposed to just looking at other data you have. So.
Yeah, that's great. I think the one area within screening that I find most fascinating personally, and Allison, you mentioned this earlier, but you give a computer adaptive test and the kid just clicks through it and you get the little red icon that's like, they were a fast clicker, or a yellow icon. But the same can happen on paper pencil tests, and like trying to figure out, and I think this is like a point you all did a really good job in the article of mentioning, is like, this is evidence from current data, but reliability and validity are not properties of the test. They're properties of the actual scores that you would collect as a teacher. And so like within a school-based setting, if you can get data back, but you can't inherently trust that it's reliable and valid, because kids might just be clicking through it. And so this is where I think some of the can't do, won't do type frameworks to try to basically parcel out, is this a true skill area where the student does not have the skill currently we need to teach, or is it more of a performance area where the kid's like, I don't want to answer this thing, I'm just not going to try, and then now you're matching that kid to an academic intervention when it actually might better be solved other ways. And so I don't know if y'all have any thoughts on that before we wrap up.
I guess I would just say I agree. I think you hit it spot on. I think we just need to make sure that we're not, and I mean, one thing that I really encourage with the teams and teachers I work with is like, it's just one point of data, right? Like we need to look at the whole kid. We might use that data. A screener is really just that temperature check, like might this kid need an intervention or not? But as we're monitoring their progress and seeing how they're doing, we're using our observations in the classroom. We're using how they're, retaining information in their interventions groups, where we have to look at the student as a whole and not just, say, oh, well, there was this one test and they were at this percentile, so that they go here. We've really got to think as a team about what does the kid need?
Yeah.
Excellent. Well, thank you so much for joining us and sharing this article. And I hope so many people go to both the free resource that y'all shared, but then also the actual empirical study. And if anyone needs help finding it, you can always email me and I will send it via email. And so thank you all so much for your time.
Thanks.
Thanks.